Hey guys, today we're going to be studying two-factor ANOVA with Kij equal to 1. ANOVA, which means analysis of variance, is going to be comparing two factors that are both within a similar situation, and these factors are going to be compared at one level, which is implied with Kij being equal to 1. I set up a table for us today with a basic problem. We're going to be comparing the candle brand to the age of the scent tester, which will give us a result of the strength of the candles that we have. You can see the different values set up. Um, the larger the numbers that we have, the stronger the candles are going to be. At the bottom, you can see I have alpha equal to 0.05. This is going to be useful for later. Remember that. I have a graph set up from this table right here, and we can see that candle 1 is obviously lesser scent, and candles 2 and 3 can somewhat be interchangeable depending on the age of the scent tester that we have. So when we're setting up a problem for two-factor ANOVA, we have to set our problem guidelines, and this is just our null hypothesis and alternative hypothesis. So what you see here is going to be an Excel spreadsheet for ANOVA comparisons. It starts off with the sum of the squares. We have the sum of squares of A, B, of the error, and the total. We have our degrees of freedom, and you can see the values of 2 under those. That's because that is 3 of each minus 1, which will get us to 2. We have our mean squared of A, mean squared of B, and mean squared of our error. We have our F values, our F critical values, which are a little more important, and our P values. Due to the P values, as you see, we are going to accept our null hypothesis for A and reject our null hypothesis for B. And that is because A is going to be less than our alpha, which is 0.05, and B is greater than our alpha, which is 0.05 as well. And we're just going to cool down here with our expected mean square values, and I just set up the equations here for you guys. They're pretty self-explanatory.